And here we're going to look at another special circumstance where we want to recognize it so that we know how to factor it. And this is going to be called the sum and difference of cubes. So another thing to look for with polynomials. Again, breaking it down, sum means addition, difference means subtraction. Cubes, in this case, again, we're not talking about the geometric shape or a block. We're talking about perfect cubes as numbers. Now, similar to difference of squares, where I said it's nice to be able to recognize some perfect squares, cubes are a little less familiar to us, probably, not necessarily, but it's really nice. So here are the first 10 perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Notice that's also a perfect square. 5 cubed is 125, 6 cubed, 7 cubed, 8 cubed, 9 cubed, and 10 cubed. Now, in terms of memorizing, I would highly recommend that you get comfortable recognizing the first 5 as perfect cubes. The more you know, the easier things will be, but these are the ones that are going to probably show up the most often in this class. So knowing those is going to be helpful. You can always use your calculator to check things as well. So if I wanted to check and see, okay, well, what is 6 cubed, right? I can always do 6 to the third, and I can see, okay, that's 216. Another thing I can do on my calculator is I could say, okay, well, what is a number of perfect cube, right? So let's say I had 500, just for example, right? And I wanted to know, is that a perfect cube? Well, what I could do is in the calculator, I can go to math, and then notice the fourth choice down is cube root. So I would do 4, and then I would type in that number. So if I type in the cube root of 500, I'd see, oh, no, that's not a perfect cube. But let's say, just for example's sake, since I already know 216, or let's do 125, because I know that's a perfect cube. So if I did the the third root of 125, I can see that that's 5. So that's how I know it's a perfect cube. So again, recognizing these is helpful, but also knowing how to check on your calculator is just as helpful. Okay, how do we factor the sum and difference of cubes? Well, first we have to recognize, do I have the sum or do I have the difference? The only thing between them is it addition or is it subtraction? So if I have the sum of cubes, a cubed plus b cubed, this is going to always factor into a plus b times the quantity a squared minus ab plus b squared. I want to point out this will never factor if you have done the sum of cubes correctly. Here's an example. So 64x cubed plus 1. 64 is a perfect cube because it's 4 cubed. X cubed is clearly a perfect cube because it is literally x cubed. And 1 is a perfect cube because it is 1 cubed. So following our pattern, the a then is 4x and the b is 1. So this becomes 4x plus 1 times a squared, so 4 squared is 16, x squared is x squared, minus a, which is 1, times b, which is 4x, so minus 4x, plus b squared, so 1 squared is 1. And again, this will never factor if I have done the sum of cubes correctly. Now let's look at the difference of cubes. Very similar, except for subtraction here, which changes this to subtraction, which actually changes this to addition. So our pattern then, if I have a cubed minus b cubed, is factors into the quantity a minus b times a squared plus ab plus b squared. Here's an example. 27x cubed minus 8. 27 is a perfect cube, x cubed is a perfect cube, and 8 is a perfect cube. 27 is 3 cubed, x cubed is x cubed, and 8 is 2 cubed. So my a is 3x, this is the a I'm talking about, and my b is 2. So this is going to factor into 3x minus 2 times the quantity a squared, so 3 squared is 9, x squared is x squared, plus b is 2, and a is 3x, so 2 times 3x is 6x, and then plus b squared. B is 2, so that's 4. Again, this is never going to factor if I did the difference of cubes correctly. Also, pay attention to the fact that the b that we're referring to is positive 2, so that's why when we do a times b, this becomes positive 6x. All right, so you have to follow the pattern. And the positives and negatives will always be correct if you're following the pattern for the sum of cubes or the difference of cubes. I'm not going to go through a proof, but you can always verify that it did work by trying to multiply this back out. Okay, so I want you to use those two examples and try to do these two examples on your own. So x cubed minus 125 and 16s to the 5th plus 54s squared. I will give you a hint for this one. Take out a greatest common factor first. So pause the video, try to do both of those. Unpause when you're ready to discuss. All right, so the first one here, this is the difference of cubes. So x cubed is x cubed, and 125 is 5 cubed. So my a is x, and my b is 5. So this is x minus 5 times x squared plus 5x plus 25. Again, the key is recognizing the a and b. Once you identify your a term and your b term, it's literally just following the pattern. For this one here, again, I had to follow my hint that I gave you, which was take out the greatest common factor, which was 2s squared. I do apologize, my s's look a little bit like my 5s. Sorry about that. So I took out a 2s squared, and then I was left with 8s to the 3rd plus 27. So 8s to the 3rd is 8 is 2 cubed, s to the 3rd is s cubed, and 27 is 3 cubed. So the 2s squared just stays here on the outside, and this factors into 2s plus 3. So a is 2s and b is 3. Times the quantity a squared, so that's 4s squared, minus a times b, so 6s, plus b squared, which is 9. Any questions? All right. Okay, so again, always look for a greatest common factor first whenever you are trying to factor or solve anything, really. We're talking about polynomials here, but this is true for anything. And if we have two terms, now we want to ask ourselves, is it the difference of squares? Is it the difference of cubes? Or is it the sum of cubes? Or none of those. It doesn't have to be one of those things, but if it is one of those things, we want to identify it and then use our pattern to factor it. And then again, if there are 3 terms, then can I factor it as I know how to factor 3 terms?